So we're going to look at an example here where we suppose you enter a lottery.
I won the lottery!
Well, who needs employees? I won the lottery too.
We both won the lottery! Why don't you win the lottery too?
The state lottery, where everybody wins.
Where 6 numbers from 1 to 49 are selected without replacement. Understanding that getting all 6 numbers is unlikely,
I've got so many tickets I can't lose.
The first number is 17.
No!
You can still win some money if you have 5 out of 6.
Woohoo!
And the second number is 3.
No!
you hope to just match 3 and still get a minor prize. What is the probability of matching 3 numbers in the drawing? So I'll say that when it comes to these probabilities that we're finishing with here, they're a little bit more complicated because getting the total number of options and the total number of options for what we want takes a little bit more thought. But truth be told, they're still fundamentally the same thing that we've been working with. So in this case, the first thing that we want to do is understand here that we're doing this problem in terms of classical probability. Which is to say, when we want to find the probability we're looking for, I'll just say that PE, it's going to be the total number of drawings underneath the number of draws with 3 matches. That is the number of drawings where you still get the minor prize. And if you want the total number of drawings, well, that's going to come from the combinations here because order doesn't matter with those 6. Thankfully, if we had order that mattered, then this thing would be a real exercise in futility. But because order does not matter, we have 49 options, and we are choosing 6 of them. And I'm going to leave this to you to verify. It'll maybe pop up in a bit of calculator work. But if you do, you'll see that the total number of options that we get here would be, let me get my decimal places right looking at this number. There are quite a few of them. 13,983,816. Yes, that's a lot. And if you want to win the major prize, you want to win the whole lottery, the number of ways to win would just be 1. So it would be 1 over about 14 million that you win this lottery. Don't go bet your life savings on that. Probably not a good bet. But anyway, that's our denominator. To get our numerator, we need to understand what we're looking for here. So if we want 3 wins, that is, we want 3 matches, well, we need that from the 6 winners, we have to select 3 of them. Because it doesn't matter what order they're in, we just need to get 3 of those right. And then from there, we have a whole bunch of other numbers. Specifically, we have 43 of them that are not winners. And we just need to pick 3 more. Because we're not looking for at least 3 winners. We want exactly 3. If we want at least 3, then we'd have other options and our number would change a bit. But in this case, we just want the other 3 to be something nonsensical and unhelpful. Where if you multiply these together, you will get 20 for 6 choose 3, multiplied by 12,341 for the remaining 3, and that will give you 246,820 total ways to get exactly 3 winning numbers. You might think to yourself, hey, that's a lot of numbers, but bear in mind what we're comparing it to. Because if we want our total probability, it would be that seemingly large number of 246,000, but divided by the considerably larger value of about 14 million. 14 million is a bit bigger. You don't need to spend as much time as I have doing math to figure that one out. And the probability here ends up being 0.018. That is less than a 2% chance of getting 3 out of 6. Which is to say, it's still a very, very unlikely proposition.
Yeah, I knew we wouldn't win. Well, why didn't you tell the rest of us? Why did you keep it a secret?
And that's about all that we're going to see from this chapter. The next thing we're going to do is get started with 4.1, where we're going to see how we can take these probabilities and present them in a manner much like what we did at the beginning of chapter 2. We're going to see how we can take these and put them into distributions so that we can better identify patterns and behavior and start learning about some specific types of probabilities as well.